Welcome back, guys. This is the Arkansas Soybean Promotion Board's Soybean Podcast. We're down in Monticello today with Dr. Terry Spurlock. He's the Associate Professor and Extension Plant Pathologist, and his funded project is on Taproot Decline.
Originally, a lot of people thought it was sudden death syndrome, and we saw some really good examples this year with an uptick in sudden death syndrome for whatever reason, where we actually had taproot decline and sudden death syndrome in the same field. And you can really easily see how the foliar symptoms of both of those diseases could be somewhat ambiguous.
So, can you give us a little background on this relatively new field problem?
It is a new disease, at least new to us, that sort of Ark-La-Mis area in the Delta, and some consultants started noticing something a little bit different. And they weren't sure if they were looking at sudden death syndrome. You know, there's a disease in cotton, it's called black root rot in cotton. They weren't sure if they were looking at that because the roots were black and deteriorated. And so that sort of started this team through, LSU, Mississippi State, University of Arkansas. My predecessor here, Cliff Coker, did some work on that, working to try to understand what this was. We've learned a lot. We still have a lot to learn, but one thing we do know is this is a significant problem for our soybean growers in southeast Arkansas. Perfect example, down in the very southeast corner of the state, in Chico County, there's some farms where I can't walk more than 2 steps without finding the disease in any field, and 2 steps more and there's more of it. Again, we don't know why it's such a significant problem in the southeast portion of the state. What we do know, though, is we can find it as far north as Jonesboro area. I actually had a trial this year in Hoxie where I found the disease. So that's not clear at this point.
It's not a soil?
We seem to find it more severe in our lighter soils. We don't yet know if that's because maybe we're planting those fields a little sooner because they're drying out sooner, right, being lighter soils.
As opposed to gumbo.
But, my colleague at LSU will tell you that he's got some silt loam soils around the station there in Winsboro and northeast in Louisiana, and he's got some fields that are really severe, just like us and just like Mississippi.
This was misdiagnosed or misunderstood for probably years and years.
It's not easy to diagnose sometimes, especially for consultants trying to cover a lot of ground, but there's when you identify a disease on a soybean plant, there's nothing to say that soybean plant, especially late in the season, has more than one disease. And so sometimes those symptoms sort of become ambiguous because there's more than one disease on that particular plant. So it was misdiagnosed until we finally discovered the causal fungus in the genus Xylaria. And it was kind of neat. The group actually got to name the disease. We got to name it Taproot Decline, which is something that you don't really get to do in your career as a pathologist very often, maybe once, and then also name a pathogen that was as yet undescribed, and so it's called Xylaria necrophora now.
So did DNA research lead to that?
Yeah, so there was some really good work done by a colleague of mine here initially in the Division of Agriculture named Bert Bloom. I guess the bulk of that description of the pathogen sort of went to a PhD student that worked for a mycologist in Baton Rouge on campus at LSU named Vincent Doyle. And so Teddy Garcia and the student, they did a really good job understanding the relationship through the genome of this particular Xylaria to other Xylarias, to some that came from historical culture collections and fungi that were from other parts of the world. It was discovered that it was unique, it was undescribed, and it was not the same as any of those other Xylaria species that you might see rotten wood in the forest and throwing up those
fingers,
very unique dead man's fingers that people talk about, and but very interesting and good work by a lot of people, and work that couldn't be done without our soybean board funding us here, the soybean board in Mississippi funding Tom Allen and Maria Tomaso Peterson and Tessie Wilkerson to work on that there, and Vincent Doyle and Trey Price at at LSU. So cooperation not only among scientists, but also those boards funding that important work.
This is a problem in the Midwest too, is it not? Or
It is not.
Uniquely as MidSouth?
Well, not so much MidSouth, maybe. I would say problematic in the MidSouth, but it has been identified in some states around the Southeast. So it's hit and miss as to where it's a problem. There's some growers in far southeast Arkansas that would tell you this is a big problem. I went on field calls this year again where it was just throughout these fields and field after field on a farm even. And so it is problematic, but those problematic areas seem to be fairly localized in this Arklamis to my knowledge. It's really an all-season disease. We know that it can infect and cause significant seedling disease. I think the foliar symptoms we see are actually later in the season infections, that stunning and that chlorosis, that yellowing. And when you pull back the canopy, many times you'll find very small soybean plants that have died there, and then the plants adjacent to that area are actually yellow and stunted. We've kind of just called it the goalpost symptom. Yeah, but it is very localized in those areas. So the yield impact, I've seen, by our best estimate, I've seen, I think, about 20 bushels across a field. You just have one corner of the field that's got some taproot decline and the rest of the field's healthy. Well, that's really not, overall, that's a negligible impact for that particular field. So it's really about the amount of the field that's impacted. At least that's what we think to this point. What's a bit troubling is that sometimes you can find fields where there's not a lot of foliar symptoms, but if you start pulling plants, you see quite a bit of incidence of taproot decline on the roots. And that leads me to believe that, you know, that's an induced stress on that plant that's not going to allow it to take up water and nutrients the way we would like it to. And so what the yield impact is in those situations, we simply don't know. It's something we're trying to understand.
So, given that this is a newer project, have we gotten into the benefits or challenges in terms of rotation?
Yeah, so what we see from this particular pathogen and disease is that for the most part, not always, but for the most part, where there's been soybean grown year after year after year, so let's say 10, 12, 15 years continuously, maybe even longer, more often we see severe taproot decline in those fields. You know, and there's always an exception. The most severe taproot decline I've ever seen in the state of Arkansas was in a field that was cotton for many years, and then about 10 years ago the farmer estimates started an annual rotation with corn and soybean.
Oh, yeah.
So you know, no rule is 100%, right? There's always exceptions.
Wouldn't that be nice?
But we do, that is our first recommendation to anyone that has an issue with taproot decline is let's rotate out of soybeans for 1 year if we can and see if we don't improve.
Find something measurable. So what are you guys recommending?
So what we would love to do is we would love to find a handful of varieties that we could say, okay, do not plant these because they're very susceptible, and some other varieties that demonstrate some really good tolerance to the disease, and we could recommend those. And we've done variety work for as many years as we've been funded on this project. We just simply haven't found those yet.
Have you only got 1 year to do a trial?
You know, we just don't get enough good looks at some of these varieties, and also, you know, disease pressure is variable year to year. And so now we've got some on-farm trials and some locations that'll start going in. We started that this year as part of this project, and next year we'll do even more of that with some bigger variety trials. And the farmers are great for recognizing that hey, we have a problem, they want to help us, let's work together. And so some of those farmers down there are just great to work with on this project and others.
Good deal. Do cover crops have a role to play?
That's a really good question. We have seen a little bit of interaction with some cover crops that maybe the xylaria fungus can infect and hang out on, maybe even reproduce on a little bit. So you could get that inoculum up a little bit, but for the most part, we're still very much learning about how cover crops could influence this disease. That work has just started by a colleague of mine that's also on this project, Dr. Alejandro Rojas, who is our soil-borne research plant pathologist located in Fayetteville. And he's also working on, which I think is really important and valuable work, the microbial community in soils associated with this disease.
Well, okay, thanks very much. That was very informative. Thanks for your time, and we'll be following up with you to see how this project's going.